Hey everybody, today we are going to cover one of my favorite topics, Swift protocols. They're one of the most important features in Swift. They're everywhere. And we're going to cover the fundamentals of what they are, why they're so important, their syntax, and we're going to have an example of how to use them. All right, first, what's a protocol? Well, let's look at Apple's definition. It's rather boring, so bear with me. Protocol defines a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. The protocol can be adopted by a class, structure, or enumeration to provide actual implementation of those requirements. Any type that satisfies these requirements of a protocol is said to conform to that protocol. So, what does this mean? That's a lot of jargon right there. Basically, it means that a protocol sets up a contract. It says, hey, if you do those things that I require, you can act like everyone would expect. For instance, what if we had a protocol called superhero? We could say, hey, you need to be able to attack, you need to be able to report, you need to have a name, and let's say you need to have a nickname. If you have those things, we're going to say you're a superhero. We don't care how those things are accomplished. We don't care who does it. But if you can say that you attack, you report, you have a name and a nickname, we're going to consider you a superhero. And so you can act anywhere that we need a superhero, I can use you. So that's the gist of how it works. Why is this important? Well, it's important because it gives us flexibility. That's the crux of the issue here is that protocols don't care who conforms to them. They don't care. Like you look at the superhero group. We got Ant-Man. We got Thor. We got Tony Stark as Iron Man. We got Captain America. We got the Hulk. I mean, look at the array of different powers and abilities. It's the same thing with protocols. Is that we don't care who does it. We don't care if it's an Ant-Man. We don't care if it's a Thor. We don't care if it's Tony Stark. We don't care if it's Bruce Banner. We don't care as long as they're able to fight, as long as they're able to report where they are, and they have a name and a nickname. We don't care anything else about them. We're going to need them to do a job, and those jobs are to fight, report, and we need to be able to call them out by name. That's all we ask. And so the same thing in our code. If we want to know if something is equal to something else, that's a protocol. It's called equitable. And I can pass that around. I can say, hey, this thing needs to conform to equitable, meaning I need to be able to check whether this is equal to some other value of its type. That's all I care. I can say, hey, are you able to compare yourself? That's all I need to know. Anything else is gravy. I don't care if you can I don't care if you're another superhero. As long as you can say whether you're equal to another superhero, that's the only requirement I have. All right, let's get into the syntax of a protocol. Protocol syntax is pretty simple. You're just defining a contract. And so think of when we are building an interface for a class or a struct, you're just saying, hey, this has a variable and this has, these functions, and some are public, some are not. So protocol is the same way. You started with just defining it as a protocol with the keyword here, protocol, then your name. And then here in our interface, we define what we need. So in this case, for a superhero, we want a var with a name, and we have to be able to get that. And we want another var with a nickname of this type, string, and we need to get it, but we also want to be able to set it. Then we have functions here, and they have to have these names with these signatures, and that's it. You can define the signatures and functions however you please, but in this case, we're going to start with this type of protocol. All right, now let's start conformance. Let's say we have a struct called Tony Stark, and we're going to conform him to the superhero protocol. All right, now the cool thing is with Xcode is that he will say, hey, he's going to yell at us and say, you're not conforming to this. And I can say, hey, well, I want to do either one of these, or I want to fix all of them. And it's going to add conformance to all of these types. And so let's quickly fill this out to report. I'm going to say Tony here. Okay, and fight. What does he do? Fire repulsors. I think that's the name of the hand cannon things he's got. And his nickname, I'm going to just say, is blank. his name is going to be Iron Man. All right. And that is the gist. Now let's create another one. Let's create a class. We're going to call this Thor. We're going to conform him to superhero. And we are going to implement him as well. Let Xcode do the work for us. Now I'm going to define this one as name is Thor. Nickname, we're going to give him a blank nickname. And report print Thor here. And fight, throw, hammer. What is the name of that hammer? Mjolnir or something like that. Okay, so now I've got two different types that conform to superhero. All right, now that we have our two superheroes, let's create a function that interacts only with the superhero protocol. So we're going to create a function on Tony Stark called nickname, where for superhero, it's going to take a superhero, and it's going to return a string for our superhero. Now note that this doesn't take Thor, this doesn't take Tony, this doesn't take any other superhero. It's just saying, hey, this is a nickname for any given superhero. So I'm going to do a switch over our superhero. And case is Thor. So now this is actually going to check the type of behind it and see if it's Thor. And we're going to return point break. And default, we're going to return an empty string. Or, we could even return the superhero dot, nickname. So whatever their previous nickname was. But Tony, he really wants to call Thor the point break. All right, now that we've got this method, let's go ahead and use it. First, let's create a Tony character. Let Tony equal Tony Stark. Our Thor is equal to Thor. Now, I want to see what Thor's nickname is, so we're going to print that out. Thor's nickname is Thor.nickname. And because we required that our nickname is both getting and setting, so we can update that. So let's let Iron Man or Tony update Thor's nickname. So Thor.nickname is equal to Tony.nickname for Thor. Now we can check that that has updated. Is now Thor.nickname, and Thor can react to that. So we're going to call Thor.react to nickname. Now, if we run our playground, we can see how that all works together. Thor's nickname is, first it's blank. Thor's nickname is now point break. And Thor says, damn you, Stark. Well, thanks for joining us today on covering Swift Protocol Basics. I hope you found it informative. Hit that like and subscribe and give this channel a little bit of boost. Thank you so much.